Now we are going to discuss another important concept, object class, right? So if you go to the definition of object class, then you will see that this class having some properties and methods, right? Now, if you go to the object class, so I'm writing object, and if you go to the object class, then you will see that this object class having some methods and properties. Equals method, right? This is reference equal method, this equals method, this is a virtual method, and this get has code, it's a virtual method, toString, it's a virtual method, right? So these are the some of the static methods, some of the virtual method, and some properties. So this is a get type is, and this is member wise clone. So we'll discuss this in later, but for now we are going to discuss toString and equals and get as code method. So this object class are having some public, and you can see these are public and this is a protected, right? So public means you can access them directly, right? And one more thing that you need to guys remember, object is the superclass of all the .NET types, whether it is a primitive data type or whether it is a reference data type, whether it is a user-defined reference data type. So object is the superclass. Either directly or indirectly, object is going to be the superclass of all your .NET type. See, now here integer is a primitive data type. Now if you look at the variable number, and once you click add dot operator, you can see equals, get has code, toString, get type, right? ToString, get type, get has code equals. So all these methods are defined inside the object class, right? All these methods are defined inside the object class, and all these methods are defined in the object class, and they are also available to this number object, right? So inside this integer, why? Because now, because this integer data type already implemented the object class. For this integer data type, object is the superclass implicitly. By default, any .NET type you take string, you take integer, you take employee, you take product, any type you take, object is the superclass. As object is the superclass, so as per the inheritance mechanism, whatever the public and protected member defined in the superclass or parent class, they are all available to the child class. This is the OOPS concept, right? We will discuss OOPS concept going further in detail. We'll discuss inheritance mechanism in detail. But for now, you just remember, if you have a parent class and if you have a child class, if child class is inherited from the parent class, then all the public and protected members that are defined in the parent class are automatically available in the child class. So that's why you can see when I create an instance or when I create a variable of integer type, and when I click on the dot operator, I can see all the object class properties, all the object class members, right? Now, if you take the string class, this is a primitive data type. String is a built-in, string is a reference data type, string str. So now, observe this. So even the reference data type str, if I dot click on the dot operator, then you will see that equals method, get has code, get type, toString should be somewhere, right? ToString, where it's toString method, yeah, toString. So all the object class methods are also available to reference type. So the point that you need to remember, if someone asks you who is the superclass of all .NET type, the answer is object class. Object class either directly or indirectly, implicitly inherited to all the .NET types. So for all .NET type, the superclass is going to be object class. As object class is the superclass, so all the object class properties and methods, right? When I'm saying all the properties and method means except the private data member, right? Except the private data member, all the public and protected members are inherited to the child class. That's why you can see inside the string str, I'm able to access the toString method. I'm able to access the toString method. I'm able to access the equals method. Why? Because why am I able to access this toString and equals method? This toString and equals method are defined in the object class, and this string class implement the object class. That means the object class properties method or whatever the members Members in the sense whatever the methods, whatever the variables, fields, constant, whatever they are, all are inherited to the child class only. Child class here, integer is a child class of object class. String is a child class of object class. Here, integer is a primitive data type. Here, string is a reference data type. So whether it is a primitive data type or whether it is a reference data type or whether it is a user defined reference data type, right? Every .NET type is directly or indirectly inherited from the object class, and hence all the object class properties and methods and field constant whatever defined in the object class are automatically available inside the child classes. Is that clear? Yes or no?
Yeah.
Right? So the object class is the superclass of all .NET type. That means all the types in .NET framework are inherited directly or indirectly from the object class. Because of this inheritance, every type in .NET inherits the toString method of the object class. Now we are going to discuss toString method. Okay, if you go to the object class, then you will see that toString method is defined as a virtual method. Now we need to understand two terms. One is virtual and what is overriding, right? So that we need to understand. Not only the toString method, but also you can override the equals method. So there is a term called overriding. We'll discuss overriding in details once we discuss the polymorphism concept, because overloading, overriding, they are basically used to implement polymorphism, right? So if you want to override means, overriding means what? Now one method is defined in the superclass, and if you want to redefine that same method in the child class, then you need to override that method, right? If you are having superclass method, let's say one method is there. For example, okay, for better understanding, let me explain you. This is class A, right? That class A having one method, let's say public void M1 is the method, right? And this M1 method is having some simple statement, right? Console.writeLine, right? So this is going to be a M1 method from A class, right? So what I'm doing, I'm declaring another method. So I'm declaring another class called B and having this method B. But what I'm doing, I'm making an inheritance relationship, right? So in this case, you can see this is a class A and this is class B. Class B means these properties or member whatever declared inside the class A are automatically available to class B. But here you can see I'm getting one warning. Why? B.M1 hides inherited member A.1. Use the new keyword if hiding was intended. What it means? So it means it is saying that you are hiding the implementation of M1 method. If hiding your implementation, you use the new keyword. But we are not going to hide the thing. We are going to override the thing. If you want to override the things, then what you need to do, you need to make the method as virtual, and then you can override the method using the override modifier, right? And once you do this, then that warning is gone. Now, this is called method overriding. So method overriding means there should be parent-child relationship. Here A is the parent class and B is the child class. And this, when you write colon A, means this is the inheritance. This is inheritance in C#. This is inheritance in C#. We'll discuss inheritance in detail. This is your parent class. And this is your child class. This is your child class. So when you make inheritance relationship, the way you implement in other programming languages like C++, Java, the same concept is also available here. Parent class members are available to the child class. Using child class object, you can access the parent class member. But overriding concept is one of the concept where you are defining, where you have providing an implementation. You are defined one method in the parent class and you are redefining the same method in the child class, right? As per your business logic, right? And if you want to redefine the parent class method in the child class, first of all, you need to mark that method as virtual, and then you need to override that method as by using the override modifier, right? So this is called method overriding. If you declare any method as virtual, then what it means? It means you are giving permission to the child class. Hey, child class, you can override this method, right? But if you are not declaring the method as virtual, then you are not giving permission to the child class. You cannot use that override modifier, right? Here, see, I remove the virtual keyword and I'm getting one error. What? Cannot override inherited member M1 because it is not marked as virtual abstract or override, right? So as it is not marked as virtual, you cannot override. So when you marked a method as virtual, then you are giving permission to the child classes to override that method. Now, if you go to the object class, then you will see that this equal method is declared as virtual. This get has code is declared as virtual. This toString method is declared as virtual. So when this method are declared as virtual, what it means? Now it means it gives permission to the child classes. Hey child class, you can override the equals method. You can override the get has code method, and you can override the toString method. Now, if I'm going to create a class, so this is a class. So am I override the toString method in this class? Can I override the toString method in this A class? Can anybody tell me?
Yes.
Yes, sir.
Why? Because by default, this A class is inherited from the object class. Na? The superclass of all .NET type, directly or indirectly, is inherited from the object class. So this means this class is also inherited from the object class, right? So this means this class is already inherited from the object class. So what he is saying, so supports all classes in .NET Framework class arrays and provide low-level service to direct. This is ultimate base class of all classes in .NET Framework. It is the root of a type hierarchy, right? So what he is saying, now this object class is the ultimate base class of all .NET Framework, right? All the classes in .NET Framework, right? Whether you write the object keyword, whether you explicitly inherit the object keyword from the object class or not, but this class is going to be the base class of all .NET Framework, right? So if you write, it doesn't make any issue, but if you remove, then also it is not going to make any issue, because by default, the superclass is going to be object class. By default, superclass is going to be object class. So by default, superclass is going to be object class, means whatever the virtual method are there in the object class, that we can also override in this class. Right? See, when I type override and give space, it gives me the option what are the virtual method that you can override. You can see equals, get as code, and toString. So these are the three three virtual methods that you can override in this class A. Then now you will ask, now you will get confused. Sir, from where these virtual method are defined? These virtual method are defined in the which class? In the
Object
class.
class.
Now, okay, come to this part. Okay, now, comment this one. So to get the intelligence, you just need to write the override keyword, and then you just need to write the override keyword, then give a space, and then you will see all the methods, all the virtual methods. Now, can anybody tell me why M1 is there?
Because it's declared as a virtual.
Yes, because because the B class parent class is A, and in A class, M1 method is declared as virtual. And for A class, who is the parent class?
Object.
So in object class, this equal get has code and toString method as declared as virtual or not. That means whenever you are declaring B, so the point that you need to remember. So for A, direct object is the base class, right? But for B, object is not the direct base class. For B, the immediate base class is A, but for A, object is the base class. So whatever public method defined in A are inherited to, whatever public method or virtual method defined in object class that are inherited to class A, and those method plus the public method or protected method of class A, all are inherited to class B. So in this case, object is the indirect base class for class B, but for A, object is the direct base class for class A. Is that clear?
Yes, yes.
Okay. So with this keep in mind, let us proceed and understand this toString and get hash code method. Right. So here you can see, whenever you use the toString method, now go to the definition. So you will see that this toString method is implemented in int32. And while implementing, what keyword he is using? Override keyword. And why it is override keyword means it is overriding the toString method in the int32 class. Then from which class this method is defined as a virtual method? It is defined as virtual in the base class. Who is the base class? Object is the base class. In the object class, this toString method is declared as virtual, and that method is implemented, and that method is re-implemented using the override class inside this int32 class, right? So whenever you call this, that means that method is override in this int32 class or not. And what this method is going to do, if you go to the definition, then if you expand, so it will convert the numeric value of this instance to its equivalent string representation. That means once you call this number dot toString method, then this 100 will not become a integer value now, no more. So it will convert it in 100 to its equivalent string, right? So here you can see the output console.read, right? So when I run this program, you will see 100 will be in the output, and that 100 is nothing but the string representation of the numeric 100. So don't consider this 100 as a numeric, consider this as a string representation of this numeric 100, right? Now let us understand one more thing. Okay, so here you can see I'm creating one class, employee class, right? And this employee class having two properties, first name and last name. I'm creating an instance, I'm setting the first name and last name. And when I call this employee.toString method, then what it is going to display? Can anybody tell me? Can anybody tell me what this employee? See, I'm able to access this toString method on the employee instance. Why? Because this employee class is for this employee class, the base class is the object class. In object class, toString method is there, and as this object class having toString method, so we can access that toString method using this employee instance, like the properties, like the method. So you can access the toString method also because this method is available to employee class via inheritance, that when I invoke this method, what it will represent? It will represent the string representation of this employee class. So what it will display? It will display the fully qualified name of this type. So what is the fully qualified name? Fully qualified name in the sense the interface name and the class name. Let's run the application. Interface name dot class name. This is the fully qualified. Now my intention is that, so when I run this toString method, instead of this fully qualified name, what I want it should display me Pranay Rao. Whatever the value stored in the variable Pranay and whatever the value stored in the route, I want to display when I call this toString method. If you want to display this output when you call this toString method, then what you need to do? Can anybody tell me?
It override that toString method.
Exactly. We need to override the toString method. See, once I type override, then you can see there is a toString method, right? So I just return toString based on toString. So instead of based on toString, what I can do is return first name, give some space, plus return last name. So once I type this, so now when you invoke this toString method, now it is going to execute the override version of the toString method. Now it is not going to execute the object class toString method. It is going to execute the override version of the toString method. Now if you run the application, then you will see Pranay Rao. Is that clear? Yes or no?
Yes, sir.
Right? So basically, when you need to override the toString method, means when you want to provide some information about your class, right? So here I'm just returning the first name and last name. And if you want, whatever information you want to expose, that you can expose by overriding the toString method, right? See, going further in your application, we are not going to use the toString method, right? But for example, suppose you want to return a string representation of your class, so you can return like this. So in whatever way, you just prepare a string and you can return that string, so that the user of your class will come to know that this employee class having this thing, right? So you can override the toString method in this way. Is that